Hi everyone. My name is Eugene. I work in a sorry. I work in a company called CleverLabs. CleverLabs is a software developer company and software development and consulting company. We develop different projects for different clients and startup projects. And today I'm going to talk about the stages of development of manual QA infrastructure and what can come out as a result. We will look at the example of a startup project, how it started and how the infrastructure evolves. After that, I will tell about the tool that we have built. So, about this startup project. We started project development from scratch in 2015. In the beginning, there were no QA people. Testing was performed by developers because it is a stage with a lot of changes and project is quite unstable. So developers can and should test their code by themselves. After that, project goes to production. First sale starts up here, and project owner and some managers with analysts start to perform testing as well. They do it both locally and on production. It's okay to test on production in the beginning because it's quite unstable and they should at least be familiar with the product. After that, as the first clients appears, there is a need of more thoughtful and careful testing. There is a need for an environment that is close to production, so we created a staging and started to use it for testing. And this is a time when we started to form a QA team, so they can perform testing as well on a production on a staging. In the beginning, we didn't write any system integration tests because the project is unstable and there's no need. We're constantly rewriting it. And but as the course functionality started to stabilize, we started to cover main features. With this kind of setup, for most projects, for many projects, for many companies, there's a way that they perform this QA infrastructure. They just have a staging and perform QA here. And we do it as well for quite some time. And here I should tell about the code delivery. We use a continuous delivery approach, meaning that each big task is divided into small tasks. Every small task has a pull request with the code changes. This pull request goes to CI/CD platform, which builds code, runs test links, runs automated tests. After that, the code goes to QA team, they do testing, and after that, the code goes straight into the production. And with this approach, during the day, there can be multiple deployments, so it's quite a frequent deployment approach. And there is a problem with this kind of setup if you have only one single staging server, because someone should constantly redeploy every pull request to this one staging. The deployment is frequent, so someone should do this. And QA team cannot leave links to bugs and errors that they have found into their test report, because the code gets constantly refreshed and staging is not a stable thing. And if the QA team consists more than one person, they somehow should parallelize their work, and they should do it either locally or to set up like this production-like environment locally, or do it on one staging, and it can be a real headache. And this is where quite a simple idea appears. Why don't we have just multiple stagings for maybe every developer and every QA person? And even more, we can have a new staging server for every new pull request. So the idea seems simple, and the implementation seems simple too. We can use the CI/CD platform that runs already our tests. and this platform can create a cloud server. For example, we can use a Heroku, which is a quite simple one. Then deploy the code, create different dependencies, and seems like it's done. We can use it, but not quite yet, because after all, after each pull request is closed, we should clean up every server. We should delete it, and we need to deploy only branches we need at the time we need. And we also need an ability to destroy this newly provided server before the pull request is getting closed. So there is a need for some kind of deployment application in our server that will handle all the things. It will react to GitHub hooks, create a server, deploy the code, create dependencies, and handle all those things. And this diagram shows how this application is being used. It is only the case of creation, so the update and delete looks pretty similar. In brief, I will describe what it is. So, when user creates a pull request, GitHub sends a hook to our application, and our deployment application creates a deployment button. So, when a user wants to create a new environment, for example, if a QA person wants to start performing testing and wants to create a new environment, the user clicks deployment button, therefore creating a new freshly QA environment. This is performed by our deployment application, which pulls the code, creates server, deploys the code, creates needed dependencies, and after the deployment is done, deployment application sends the comment about successful creation, and the user now can use the environment. So we built this application and started testing it, using it, how it fits our needs and how it suits our deployment system. And after using, we noticed that we need more features besides this core functionality of only deployment. We need a notification into the pull requests. Also, we need links to every application that is created in pull request alongside with credentials for every test users, so that the QA team can just open pull request, click the button, and after that just click the link of new application and use it. So we implemented this without any problems because we are quite familiar with the code base that we have wrote. And time passes and we need logs because sometimes application is fails, sometimes migrations doesn't work because it's a pull request, it's not like a complete feature. So we added logs. In case of failure, our application writes logs into the pull request with all the backtrace, so the developers can debug the code. And this application, we have built this application and we used it for quite a long time because it was really awesome and our team loved it and everyone used it. But in time, more problems started to appear. Our application became quite slow because the startup project is growing and there's a lot of needs like resources and database space, and this became quite expensive. And at this time, our client decided to do a staff cuts, so the QA team now consists of only one person, and there's no need of our application. And all of this came out as a decision of giving up the instrument. But we decided that this approach of having a multiple stagings for every pull request and having a tool that handles it is really great. We cannot use the old deployment application because it was built specifically for the project, but it was quite a long time since the creation, and many other tools that do the similar work started to appear. So we started a research about these tools that already present in the market. And so our list of needs is quite simple. We want an application that is able to deploy on demand by clicking the button, that is able to deploy multiple repositories at once with a different branch in every repository, so that the user can write the Git reference for every repository. Also, we wanted a tool that is quite flexible and not so expensive. And we didn't really find the tool that is fully fulfills our need. So, inspired by the previous implementation, we decided to build our own tool, our own more flexible, more general purpose and open source tool. So we started the development and called the tool Deploy QA. Now I will describe the tool, describe what we have built at this time. The main purpose of the new application, the main idea is to deploy on-demand staging environments for small and medium projects, so that users can deploy production-like environments by clicking the buttons in pull requests or clicking the buttons in our application. So how to use it, how to start the deployment, how to set up. A user can install the application in their GitHub or GitLab repository, set up needed dependencies, write needed environment variables, write a startup command or maybe some migration or database seeds command, and it's done. Now after that, the user can deploy can create these environments by clicking the buttons in pull requests, which is quite a simple stuff. We decided that we will use, for the first implementation, we will use a Heroku because it's quite simple for the first iteration. And our dependency system, our add-on system, uses the Heroku one, and also it creates we added dependencies for the third-party services, like for example Amazon S3 buckets. It is really handy for every new environment to have its own data storage, because they are separate and it's quite like production. You don't need to worry about the application is interfering with each other. So yeah, it's like separate databases but data storage. So every dependency is quite separate. And the credentials for every dependencies is passed to the application by additional environment variables. And we also improved the management of deployed applications. And you can see the screenshot on the slide. The design is quite raw because we currently focused on development, but later we will somehow change it. So these links are actions. They're called actions, and this is all what you can, and also a terminate button. All what you can do with the deployment application, deployed application. So these are reload if you want to restart server, update code if you want to manually deploy a new code, database dumps, so you can create database dumps or like download or upload database dumps. This is really a cool feature because, for example, if you want to test like reduced production data on your staging, you can just upload it on the staging, and it's quite handy. And also, if you want to debug this newly created application locally, you can download database dump and use it locally and debug some code, for example. Also, there is edit environment keys and link to credentials of every add-on. There is a performed action, so every action writes into this table, so you can see which action was performed, who is the author of the action, and when it was. And behind every action log, there is a build log, so you can see the backtrace and the whole build log. And also there is a name, repository, Git reference, and link to the application. Also, as I mentioned in the requirements, our application is able to deploy multiple repositories at once. For example, if you have two big services and every service is in own repository, you can install deploy QA on every repository, and during every deployment, they will deploy our deployment, deploy QA will deploy all services all together and pass a link to each other into the environment variables. And here you can see how to create. For example, you have a main independent services, and you can write Git reference for each of these services. Yeah, and there you can see how those buttons in pull requests looks like. Those are just images which are just links to our application. So the first button is to unconditionally create a new environment. It will just create without any interface. The second one is creates this dialog, so you can write Git reference for every service. And the third one is a settings, so you can see the pull request in our system. To wrap up all the talk, what problems does deploy QA solves? If you have a staging environment and you have struggles to manage it, you don't have a system of who is deployed, when and how, you can use deploy QA to replace the system with a on-demand static environments for every pull request. And if you maybe doesn't have a staging, you can start to development of your staging infrastructure by using the deploy QA. Or maybe if you just want a tool that is can quickly create on-demand production-like environments, for example, for demo purpose or maybe for sandbox for your client, you can use deploy QA as well. Deploy QA is an open source project. You can find code on GitHub. There's a link. And also we currently develop our project so clients can use it as a SaaS platform. So all the links are on the slide. And that concludes my talk for today. Thank you all for your attention. And now I'm happy to answer all the questions you might have. If you have any questions, I can answer. Okay, thank you.